Alrighty guys, we're ready to go. We're jumping into 12.2 and we're going to do some solving of right triangles today. Let's do it. Okay, here we go. Exact trigonometric ratios you can find for 30, 60, and 45 degree angles. We did that in the last lecture. But anything else you used to, back in the day when I was a kid, we had to use tables. But now we get to use calculators, and that's awesome. So I'm going to model that for you here, and hopefully we'll figure this out together. Calculators and computers are used to find the ratios for other angles, and it's super simple, a big deal at all. So solving a triangle means finding all the other angle measures and the side lengths of a triangle from the given information. Most of the time, you'll have one side length and you'll have one angle, and you'll have to figure out the rest of it. And it's really not that hard. Let me show you how this works. If I'm given this triangle here, triangle ABC, and all I'm told is the length of BC and the measure of angle B, I can tell you everything else about this triangle. It's crazy. I know this is a right triangle. This only works for right triangles. If you're given something that isn't a right triangle, you've got to somehow divide it up into right triangles for this to work. So here we go. Measure of angle A, this angle down here, is super simple to get. The sum of the interior angles of a triangle is 180 degrees. This is already 90, so all I've got left is the other 90. This is 72 up there at angle B, so 72 from 90 gives me 18 degrees. That was easy. That was so chapter 2. Alrighty, tangent of 72 degrees then will let me figure out what B is. 72 degrees, the tangent is opposite over adjacent. So tangent of 72 is B over 8. Tangent of 72 degrees, opposite over adjacent. Pause the video if this doesn't make sense and say that to yourself and look at it until it does. Okay, now they're going to just do the math here for you. B equals then 8 times the tangent of 72. Why? Well, because this is a division, so we're multiplying by the denominator to get the denominator over here, right? So multiply both sides by 8, and I have B by itself. 8 times the tangent of 72, 8 times the tangent of 72, and that is B. Now, what is B? B is 24.6 centimeters. Huh? How do you know? Let me show you. Let me show you. Let me get my calculator. There you go. Okay, so here I have this. Oh, and I've already done it. That's cool. Here I have this example scientific calculator, much like what you will have, I'm sure, or something you can grab on your phone. So if I have 8 times the tangent of 72, for most scientific calculators, you got to type in the angle measure first, 72, and then you hit tangent, and that will give you the tangent of 72. It's a very long, non-repeating, non-terminating decimal. Okay. Don't write all this down. Okay. Now, that is the tangent of 72, but I'm after 8 times the tangent of 72. So times 8. 24.621468, yada, 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 yada. 24.6 is good enough for us. So that is the length of B. Let's get out of this. So the length of B is 24.6. So I can put that in. Now, the cosine of 72 is the adjacent over the hypotenuse. 8 divided by C. Cosine of 72 is 8 divided by C. So now I need to do a little bit of algebra here to flip this around. C times the cosine of 72 degrees equals 8. I could do a little bit of other flipping around and figure that C equals 8 times the cosine of 72. 8, did I say times? Divided by the cosine of 72. So let me get my scientific calculator back out. Let's clear it up here. And let's say 8 divided by, and then I need a parentheses, 72 cosine, close parentheses. And what is that? That is 25.88854, yada, yada, yada. So what I did there is I said 8 divided by, and then I made a parenthetical statement to put all this in so that I got the right thing. You could also say cosine of 72, what is that? And then write that down. And then 8 divided by that. That's just a little more work. Okay? But either way, I found out that C is 25.888. And yes, round up to 25.9 and call it good. So we just solved that triangle. Woo! Write a letter to your mama. Let's get excited. Now you can do this exact same thing backwards. Instead of having the sides instead of having the angle and figuring out the sides, if I have the sides, I can figure out the angle. That is still the sine, cosine, or tangent function, but you're backing through it. Now, just like the backwards of multiplication is division, and the backwards of addition is subtraction, and the backwards of squaring is square rooting, right? The opposite function. Sine, cosine, and tangent all have opposite functions, and we use them. We say sine, and then we'll put a -1 in the exponent. And so we're saying the opposite of sine, the opposite of cosine, the opposite of tangent. Or you can say arc sine, arc cosine, or arc tangent. The arc is a little confusing. It refers to the fact that that means like the antithesis or the opposite of in Greek. But more often they'll write out sine -1, and they'll use that to mean I'm backing through the same function. So instead of having the angle and finding the sides, I have the sides. I'm going to find the angle. And so that is something that we're going to demonstrate for you here. So the inverses of the trigonometric ratios are given for you here. The inverse sine, the inverse cosine, and the inverse tangent. So if the sine of A is x, then the measure of A is the inverse sine of x, whatever this ratio is. If the cosine of A is x, then the measure of angle A is the inverse cosine, or the arc cosine of x. So it's the same ratio. If I have the ratio, if I have the angle, I can get to the ratio. If I have the ratio, I can get to the angle. Okay. Some examples here of this triangle. If the sine of 60 degrees is radical 3 over 2, sine of 60 degrees is radical 3 over 2, then the inverse sine of radical 3 over 2 is 60 degrees. So again, I have the ratio and I'm going to the angle. This table is in your book. Don't bother copying it down. But it will help you remember which way you're going. So let's do that. Here's a triangle ABC. I have two side lengths. I know it's a 90-degree triangle, but I don't know what the other angles are. I can use trigonometric functions to figure them out. They want me to figure out the measure of angle A. So if I'm looking at angle A, if this is my theta, then this and this are sine, right? Opposite over adjacent. If they wanted me to find B, then that would be, I'm sorry, I said adjacent, opposite over hypotenuse. If they wanted me to find B, then it would be adjacent over hypotenuse, and I'd use cosine over here. You'll start to see triangles in such a way that when you have opposite and hypotenuse, you'll automatically say, oh, that's the sine. So you'll get there, I promise. So sine of angle A, because it's opposite over hypotenuse, is 3 over 5, opposite over hypotenuse. 3 over 5, if you do the division, is 0.6. So if I go to my calculator and I say, hello, Mr. Calculator, what is 3 divided by 5? Oh, that's 0.6. Mr. Calculator, what is the opposite of the sine of 0.6? That's 36.869, 36.9 degrees. Now, how did I get that? On most scientific calculators, there will be a shift or a arrow or something like this. And this arrow means do something other than the normal button. And in this particular calculator, arrow turns sine into inverse sine, cosine into inverse cosine, and tangent into inverse tangent. So here I'm going to be typing in a decimal number. I hit these buttons and it'll give me a degree. All right? You can play with your calculator and become familiar with that. Here they want me to solve triangle ABC, and I've been given that it's a right triangle, and I have 11 and 17. So no matter which way I start with A or B, the first thing I'm going to do is use a tangent function, because I have opposite over adjacent if I'm going to do B, or I have opposite over adjacent if I'm going to do A. And so here I have tangent of angle A is 17 divided by 11, 17 divided by 11, opposite over adjacent. If I divide 17 by 11 and then hit opposite tangent or inverse tangent, it's going to tell me 57.1 degrees. Let's do that just so that you've seen it, right? Okay, so I have, let's get out of the opposites first. 17 divided by 11 equals that number. Now I want to say that's my ratio. What's my angle? Opposite tangent, 57.09 or 57.1 degrees. So that's the measure of angle A. So 57.1 goes in here. What's the measure of angle B? Well, I could do what they did here. The sum of the interior angles of triangles is 180. 180 minus 90 is 90. 90 minus the 57.1 that I figured out over here gives me 32.9. That's fine. Or I could have done the inverse tangent of the other side. I could have done 11 over 17 inverse tangent, and I would have gotten the same thing. Okay, either way. And then I need to know the length of this. They use the Pythagorean theorem, but you could also use cosine or sine of these angles, because once you have these two angles and these two sides, you could say, oh, sine, what's the opposite divided by the hypotenuse of this angle? And you'd figure it out. Here they use the Pythagorean theorem, and they've calculated that it's 20.2 inches. So these are the kinds of things that you'll be doing. Here's a neat application of this concept. You're in a survey airplane flying at exactly 7,000 feet, and you sight to the top of the mountain. You discover that it's a 7.5 angle of declination, there's a neat vocabulary word, from your horizontal to the peak of Mount Mitchell. And then you fly another 2,400 feet, and then you're immediately over the mountain. So how tall is the mountain? Pretty cool. Tangent of 7.5 degrees is x over 2,400. Tangent of 7.5 degrees, opposite over adjacent, x over 2,400. Solve for x. So 2,400 times the tangent of 7.5 degrees is about 316 feet. So this is 316 feet. You were at 7,000. 7,000 minus 316 puts the altitude of the mountain at about 6,684 feet. That's pretty cool. You'll do some other word problems in this section. Remember to always draw a diagram. Okay, if you have any other questions, put them in the comments field below, and I'll get to them as quickly as I can. Otherwise, we'll see each other in class, and we'll keep working through this. Isn't trigonometry phenomenal? Praise God for trigonometry. Until then, Jesus loves you, and so do I. Good night.